Using SolidWorks simulation software, you can easily analyze a system of dynamic force. This occurs when a force is repeatedly applied, but the failure type is not fatigue. The options for our dynamic analysis are shown graphically so that we can easily recognize them. These options include response spectra input, steady-state harmonic input, and random vibration excitations. For this sheet metal part, we can use shells to simplify the meshing and solving process. With sheet metal, the outside surfaces are normally all tangent, so you can select all faces with just a few clicks of the mouse. You can apply separate materials to the shells or use the default SolidWorks material if it's already selected. If you do not have a certain material in your library, you can create custom materials on the fly. As we continue to set the materials, notice the combination of solid geometry and shell geometry in our analysis. SolidWorks simulation gives you the tools to choose the most efficient mesh for any given problem. To simulate how this assembly is restrained, just click on the mounting holes and they will be fixed in your analysis. You can select the load type from a list, in this case, uniform base excitation. Then indicate the edge where the excitation will occur and that you are going to use an acceleration type. Next, specify your acceleration value, in this case 1g. We are going to use a curve-based variation with time, where we can enter the data directly or load the data from a file. You can apply global damping to stabilize the model. Our results options are customizable so that we can meet our non-standard information requirements. We are particularly interested in how the chip on the PCB will react to our dynamic input. Next, we need to tell SolidWorks simulation how to treat all the connections between the parts. First, we select the holes where we have screws holding the cover to the chassis, and make these bonded. This means that there is no relative motion between the faces. Now let's continue and define the rest of the contact points. Next, we let SolidWorks simulation create the mesh. One of the many time-saving features of SolidWorks simulation is the ability to specify several frequencies to analyze simultaneously. You can simply select the Run Frequency option and let SolidWorks simulation do all the work. After the linear frequency analysis is completed, we then run the dynamic analysis. Once completed, you have many options for displaying the graphical results. For example, you can show the stress, displacement, or acceleration. We are after one particular result, the time history graph of the node, which we previously selected on the chip. As you can see, SolidWorks simulation allows you to easily analyze even the most complex problems, giving you even greater confidence in how your designs will perform when exposed to real-world physical challenges.